Have NASA's Senior Climate Advisor, Dr. Kate Calvin. Great to have you here.
Wonderful to be here.
Perfect. So let's take a look at some video of EMIT, Rob. So
Okay.
EMIT is going to be attached to the outside of the space station,
Yes.
and it's going to study mineral dust. But what is mineral dust?
So mineral dust are the tiny particles of rocks in the dry land regions of our planet that under conditions of high winds are launched into the atmosphere. In the atmosphere, because they can be different compositions, they can heat or cool our planet, play a role in cloud formation, and many other impacts. Right now, we know about mineral dust by about 5,000 different measurements that have been analyzed around the Earth. When EMIT is done, we will have 1 billion direct observations of the minerals in these dry land regions to advance the science of how mineral dust can heat or cool our planet.
And I think it's important to understand for people that, we're not just focused on these arid regions. When you have dust storms, you can see a dust storm in Africa end up affecting us in Texas, per se. So why is it important to study these dust storms, and in particular, to understand how they might heat or cool the Earth?
Well, as you point out, it's a global phenomenon on every continent except perhaps Antarctica, and that dust can travel thousands of miles from Africa to Florida to Texas, and it has impacts throughout the Earth system there. And then heating or cooling, when you have a global phenomena, you've got to take it into account. Are those dust particles absorbing energy, heating our planet, or are they scattering light back into space and cooling our planet? So we need this information so the Earth system models become more accurate, so we understand what's happening now and in the future. And those are the two primary objectives of EMIT.
Yeah. So, Kate, it sounds like EMIT is going to be a real tool for us when we're studying climate change and just the Earth's climate. And it's no surprise that EMIT is one of a fleet of Earth-observing spacecraft.
Yeah, one of NASA's most important missions is our home planet. We have more than 24 satellites and instruments in orbit, including several on the International Space Station, that observe the Earth. So we can see things like carbon dioxide, vegetation, changes in the mass of ice sheets, and much more. And once EMIT is put onto the International Space Station, it'll join that fleet.
Wow. And I do know that it's not just what we have orbiting the Earth. There's also a lot of research being done on the ground. So when you consider this whole portfolio of climate research that we're doing, how will this help us address climate change?
Well, the more we know about the planet, the more we can use that to provide to local decision makers, stakeholders, and the public about what's happening on Earth.
Awesome. Guys, thank you so much. I appreciate your time.
Thank you.
And EMIT isn't the only experiment inside Dragon that will study Earth's climate. Students from MIT built what you're about to see on the screen here. This is called Beaver Cube, and it's named after the school's mascot, Tim the Beaver. It's a small satellite about the size of a shoebox, and once deployed, it will measure cloud properties, ocean surface temperatures, and ocean color to analyze Earth's climate and weather systems. T-minus about 11 minutes and counting from liftoff of NASA's and SpaceX's 25th commercial resupply services mission to the International Space Station. Let's bring back Shiva now to tell us more about Dragon.
Thanks, Megan. Now, Dragon is capable of transporting people as well as environmentally sensitive cargo to and from Earth orbit, like we are on today's mission. Starting from the top of the nose cone to the bottom of the trunk, it stands about 27 feet tall and is made up of two main sections. The pressurized capsule and
thrust vector control actuators. They are underway. This is often referred to as the engine wiggle test. This is when SpaceX moves the thrust nozzles slightly to make sure that the guidance hardware is go for flight. Again, that was a great view of the transporter erector tilting back. SpaceX does the exact same checkouts of the first stage engines, and that happens just seconds before ignition. At the time of launch, 8:44 and 22 seconds p.m. Eastern Time, the International Space Station will be over the Pacific Ocean, 257 statute miles in altitude.
Now, we actually heard just about 30 seconds ago that liquid oxygen loading is complete on the first stage. And coming up here, just under 20 seconds, we'll hear a similar call out on the second stage. That will wrap up propellant loading on Falcon 9 in preparation for launch. At this point, Dragon is performing its final health checks to make sure we're ready to go for rendezvous with the space station about 38 hours from now. And I love the shot of the pad. You can see the clouds forming around Falcon 9
Stage 2
from
lock
that
load complete.
cooling. There's a call out there for LOX load complete. You can hear or see the water vapor condensing and forming
Dragon is an auto
clouds
idle.
around Falcon 9.
Yeah, you sure can. And just a few minutes left in twilight. A little bit of illumination makes it nice. At T-minus 1 minute, Dragon will transition to internal power. Falcon 9 computers will enter startup mode and begin final pre-launch checks, guiding the rocket through the last seconds before liftoff.
Falcon 9 is in startup.
Here you have the call.
Dragon is in countdown.
Both stages are now pressurizing for launch.
LD is go for Falcon 9, CRS-25 launch.
So range is go, weather is go.
T-minus 30 seconds.
It's a beautiful time of day to watch this launch if you're out on the beach.
T-minus 15.
And here we go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition. And liftoff. Liftoff of SpaceX's Falcon 9 rocket, launching Dragon on the 25th mission to resupply the International Space Station with cool science and a new advanced instrument to more effectively study our planet's climate.
Power and telemetry nominal.
We are 50 seconds into flight, successful liftoff from the Kennedy Space Center, Launch Complex 39A. Falcon 9 is heading towards its next major milestone. For the point of highest stresses that the vehicle will experience during ascent. There's the call out for maximum dynamic pressure. So from here, the stresses on the vehicle will get lower and lower as we raise our altitude. Coming up, we've got 5 events back to back. The first of those will be main engine cutoff, or MECO. That's where all 9 Merlin 1D engines on the first stage will shut down.
I'm back chill.
Following that will be stage separation, where the first and second stages will separate. The first stage will flip around to make sure it's headed back towards the landing site and our drone ship named A Shortfall of Gravitas. And then the second stage will ignite its Merlin vacuum engine to boost Dragon into low Earth orbit during second engine start number 1. We just heard the call out there for engine chill-in on the second stage engine starting. The last event is the boost back burn on the first stage. That's to reduce the velocity of that vehicle as we prepare for atmospheric entry. Now, all of those events happen over about 45 seconds. And again, they are main engine cutoff, followed by stage separation, first stage flip, second stage engine start, and then boost back burn start. All those happening in just about 5 seconds.
MECO. Stage separation confirmed.
Fantastic sight.
And back startup.
So the first 3 of those events are complete. And now the boost back burn is underway. The shot on our screen right now is of the Merlin vacuum engine on the second stage. And as this view toggles, you may catch the first stage. It is firing its Merlin 1D engines that burn on the first stage, lasting about 30 seconds. You can see the plume on the first stage on the left-hand side of your screen as we're doing the boost back burn.
Stage 1 boost back shutdown.
Successful shutdown of the first stage Merlin engines for the boost back burn. Second stage engine continuing to burn. That'll continue to burn until about the T plus 8 minute and 40-second mark into the mission. Now, if you're just joining us, welcome to our 25th commercial resupply mission to the International Space Station for our customer NASA. You're watching our 30th mission of 2022 and the third Dragon flight to the International Space Station this year. We lifted off just about 4 minutes ago from the Kennedy Space Center in Florida. On your screen are views of our first stage on the left-hand side of your screen with its grid fins deployed periodically, controlling its attitude to make its way back home. On the right-hand side of your screen is a shot of the Merlin vacuum engine on the second stage, performing its burn. It'll continue to burn for about another 4 minutes to take Dragon up to low Earth orbit. Now, speaking of the entry sequence on the first stage, to make its way back to that drone ship, it's going to have to execute 2 more burns. The first of those is the entry burn, where we'll ignite 3 of the Merlin engines, and that helps slow down the stage as we enter the upper part of the Earth's atmosphere. Following that, there will be a second burn, the landing burn, and there will only ignite a single Merlin 1D engine that'll bring the vehicle speed down to 0 for a soft touchdown on the drone ship. We've got some great sunlight on the vehicle, and you're periodically seeing some plumes of white. That's actually from our nitrogen gas thrusters that are helping to keep the first stage oriented, engines down. Get through that entry burn. The grid fins, which are deployed, you can see 2 of them on your screen, will then take over control as we start to get atmospheric authority. The first stage will only use those grid fins to steer back towards our drone ship. So entry burn expected to start about 10 seconds for now.
1 FTS is saved.
Just taking a quick look in, stage 2 engine performance, about nominal. Continuing to burn. We've got about 3 more minutes for that burn.
Stage 1 entry burn startup.
So you can see the velocity on the first stage, bottom left-hand side of your screen, rapidly slowing down as
Stage
we
1
fire
entry burn shutdown.
the entry burn. That burn only lasting about 15 seconds. And now we're doing a quick attitude correction to make sure we're pointing the heat shield down. And that entry burn and the plume coming back on the stage ends up depositing a small layer of carbon on the vehicle, which is what gives our first stages that awesome sooty look once we've reflown them. Now, Falcon 9 also has 4 landing legs. They're made of carbon fiber and aluminum honeycomb. They're placed around the base of the rocket, and they'll deploy just prior to landing during the landing burn. If we're successful in recovering this Falcon 9, it'll mark its 5th successful landing and our 130th landing overall of a Falcon 9, including Falcon Heavy missions. So landing burn coming up shortly.
Stage 1 landing burn.
Keep an eye out on the speed on the left-hand side of your screen. That's the velocity of the first stage. We're going to see that come all the way down to 0. On the right-hand side of your screen is our drone ship. And also keep an eye out on the left-hand side of your screen for landing leg deploy.
Stage 1 landing leg deploy.
People real excited behind me. Right in the middle, 5th landing for this Falcon 9, 130th landing overall for an orbital class rocket. Beautiful sight to see. Now coming up next is second engine cutoff number 1, or SECO 1. We'll expect the Merlin vacuum engine to stop firing just about 30 seconds from now. It's carrying the Dragon spacecraft to its drop-off orbit around our planet. After we complete second engine cutoff number 1, we'll do a quick check to make sure that the burn performance is as expected.
Stage 2 FPS.
We're in the targeted orbit. We usually hear that called out as a nominal orbital insertion or a good orbit call out on the loops.
And back shutdown.
So you heard a call out on the loops there for shutdown of the Merlin vacuum. There's nominal orbital insertion. So that means that the ground teams have assessed the orbit and stage 2 is right where we want it to be. And of course, that also means that Dragon is right where we want it to be since it's been arriving on the the second stage this whole time. Now, if you're just joining us, we're about T+9 minutes, 20 seconds into the mission. On the screen next to me is a view of the Merlin vacuum engine with Earth behind it on the second stage. Now, the second stage has one major task remaining, that is commanding separation of the Dragon spacecraft just a few minutes from now. And we're hoping to have video of separation from the top of the second stage. We actually got a quick glimpse of it before, but we've got a camera that looks up into the trunk of Dragon and gives us a little peek at some of the cargo that we're taking in that unpressurized section. You can see the EMIT payload there on the left-hand side of the screen. Now, the CRS-25 capsule will be joining the Crew 4 vehicle, Capsule Freedom, which is currently on orbit. So we'll be back to dual Dragons docked at the International Space Station. CRS-25 will be headed to the Forward Harmony port on Node 2. And we're expecting it to arrive on the 16th around 11:20 a.m. Eastern Time. There, it'll spend about 1 month attached at the International Space Station. Now, as for the cargo, today we are delivering more than 5,800 pounds of science, research, crew supplies, as well as vehicle hardware to the orbiting lab and its crew. And amazing, more views inside the trunk. Now, at this point, the second stage is performing its final checks to ensure that we're not imparting any unnecessary momentum or spin to the Dragon spacecraft. Once those calculations are complete, Dragon and the second stage will command separation. And shortly following separation, Dragon will conduct a series of health checks on its thrusters, its cabin, thermal, and solar systems, its navigation systems, in preparation for the upcoming 38-hour mission to the space station. Got about 30 seconds to go. If you're just joining us, we're looking at the second stage. Coming up real shortly to Dragon separation. This particular Dragon marking its third flight, and it also the first third reuse of our upgraded cargo vehicle. This view looking into the trunk of the Dragon capsule. That's our unpressurized portion of the vehicle. That's some of the payload that we're taking up to the International Space Station.
Dragon separation confirmed.
Phenomenal. So with that, CRS-25 gently floating away from Falcon 9's second stage. Again, coming up next, we've got some service section Draco checkouts, as well as nose cone opening. But that's actually going to complete my coverage here from Hawthorne. So I'm going to pass it over to Sandra at Houston to check in with the teams there. Sandra?
And thanks, Shiva. Welcome back into the International Space Station Flight Control Room. That was a beautiful launch from here in Mission Control Houston. Right now, we're just standing by for confirmation of the nose cone deployment. And we did just get confirmation that the nose cone was successfully deployed. That nose cone does cover the docking hardware, the navigation and rendezvous sensor, and the 4 forward bulkhead Dracos. The nose cone will stay open until the end of the mission, until after deorbit burn and just prior to re-entry. If you are just joining us, NASA and SpaceX's 25th commercial resupply mission launched from Pad 39A at the Kennedy Space Center in Florida at 7:44 p.m. Central, 8:44 p.m. Eastern Time this evening, and is currently in orbit and heading to the International Space Station. Dragon is filled with over 5,800 pounds of cargo and supplies, including a variety of science investigations, hardware, and fresh food for the crew on station, such as apples, oranges, cherry tomatoes, onions, carrot, garlic, tahini, and even shelf-stable cheese. On board the International Space Station right now is the 7-person Expedition 67 crew, who I'm sure is looking forward to these fresh foods. The crew includes NASA astronaut Bob Hines, European Space Agency astronaut Samantha Cristoforetti, Roscosmos cosmonauts Denis Matveev, Oleg Artemyev, and Sergei Korsakov, as well as NASA astronauts Jessica Watkins and Kjell Lindgren. And we're just continuing to stand by on that nose cone deployment checkout. Dragon is slated to dock to the International Space Station on Saturday at approximately 10:20 a.m. Central Time. NASA astronauts Bob Hines and Jessica Watkins will be monitoring the approach of Dragon. Earlier this week, NASA astronaut Bob Hines and Jessica Watkins spent some time reviewing procedures on a computer ahead of Dragon's automated rendezvous and docking. And the two flight engineers were also joined by NASA astronaut Kjell Lindgren, who helped stage cargo that will be returned inside Dragon at the end of its month-long mission at the orbital lab. And we are continuing to stand by for confirmation that the nose cone checkouts are complete.